All right. I hope you did okay with the last section. Um, you've gone through what everything is, hopefully looked over the vocabulary again. And so now it's time to start talking about how do we use these transformations? What do they mean? How do we notate them? And so if you look at this next section that we're about to do together, it says describe each of the following mapping notations in words and give an example using the point A is -3, 2 for X and Y. Assume 0, 0 is the center of the transformation where appropriate. All right, so when they're talking about the point 0, 0, they're talking about the origin of a graph. If you have a graph, the origin right here is the point 0, 0. So we'll see where that applies in just a minute. All right, so starting out, you have xy maps to -xy. All right, so what are they even talking about? What does all of that mean? It means that this is the pre-image. This is where it was, and this is where it goes. So this is the transformation that happens. It goes from xy to -xy. All right, so what is happening here? Well, this is where you're going to want to grab your cheat sheet. It goes from xy, right down here. It goes from xy to -xy. So I look at my cheat sheet and I say, okay, right here is xy to -xy. So that's over the y-axis. And it's a reflection. Reflection over the y-axis is where xy goes to -xy. So that's my answer for the first one. Reflection across y-axis. And then it says, let's try this out for the point -3, 2. So I'm going to come back to this, and I'm going to go to -3. Now this is the x, this is the y. I always start with the x. So -3 is 1, 2, 3, and 2 would be right there. And that's the pre-image. The image is what happens when -3, 2 maps so that the x becomes negative. So what's negative of -3? +3. And the y stays the same. So it's 3, 2. So I would go 1, 2, 3, 1, 2. And there's the image. So the pre-image and the image. Okay, this is what it originally was, and when I reflected it across the y-axis, there's where it lands now. If I were to fold this graph along the y-axis, okay, you can see that they would touch along that fold because they're an exact reflection across this line of symmetry. Okay. Number 2, it says xy maps to x plus a and y plus b. Well, let's grab our cheat sheets again. And you notice that when there's addition, plus or minus, you're talking about a translation. xy maps to x plus h or y plus or minus k. So if you add or subtract, then you are doing a translation. So this would be a translation. Okay, so it's xy is -3, 2. And that maps to, it's going to be x plus a and y plus b. Now, they didn't give us an a and a b. So let's just make one up. And I am totally just making this up. I'm going to say a is 1 and b is 2. Okay? I'm just making that up. If A equals 1 and B equals 2, then the mapping would be at x plus a, which would be -3 plus 1 is -2, and 2 plus b, which is 2. 2 plus 2 is 4. So it would be at -3 to, or go from -3 to -2 4. So let me show you that one. -3 1 2 3 1 2 goes to -2 1 2 3. I would have not gone high enough, but it's going to be just off the chart here. -2 4. It's going to be right up here. So it slid from here to here. Okay, so that is a translation. When it slides, it's a translation, and that's what it did. Okay, next you go from xy to x negative y. Xy to x negative y. So if I look at reflections, xy to x negative y, this is reflecting over the x-axis. Now remember our first one, the x changed from positive to negative, and it was a reflection across the y-axis. But now our y changes from positive to negative, and it's a reflection across the x-axis. Now, do I expect you to remember every bit of this? No, I sure don't. That's why I'm giving you the cheat sheet. But if you don't use it, you're going to be at a loss on this, because I still use it, and I've been doing this for a long time. So it gets really confusing if you don't have that cheat sheet handy, and you have to end up graphing it every single time to see what it does. And so just keep your cheat sheet close by. All right, so this is going to be a reflection across the x-axis. And if I go from -3 to, where am I going to go? Well, x maps to x, so it stays the same. And y maps to negative y, so 2 turns into -2. Okay? So that is the reflection across the x-axis, and the x-axis is the one side to side. So let me show you this one more time. I'm not going to keep doing this every time, but from -3 2 to -3 -2. So this time it reflects across the x-axis. Last time we had a reflection, it was across the y-axis, up and down. So it reflected from side to side. This one is across the x-axis, so it reflects from top to bottom. Okay, now we have xy maps to y negative x. So this one not only changes the x to negative x, but it reverses the order xy to yx. So here's an xy to yx, but it didn't change anything. So let me keep looking. If I come down here to the very bottom, I see some reverses. And which one changed? It was the x. It went from xy to y negative x. So I see all the way down here at the very bottom, the very last one, this is going to be a rotation. Now, what kind of rotation? Well, you can either go 270 degrees counterclockwise, or you can go 90 degrees clockwise. And you can see that would be the same thing if you look at a graph. Okay, if you're right here and you go 90, 180, 270, you would wind up right here. Well, that's counterclockwise, or I could go clockwise 90 and I'd be at the same place. So 270 counterclockwise is the same as 90 clockwise. 90 counterclockwise is the same as 270 clockwise. So 90 and 270 end up in the same place. Just depends on which way did you go to get there. So I'm either going clockwise 90 or counterclockwise 270. So I'm just going to say clockwise 90. And so number 4 is going to be a rotation clockwise 90 degrees. Now, if you put counterclockwise 270, would you be wrong? No, you would be still correct. I just picked one. Okay, so mapping the point, I have -3, 2, maps 2. Now, the y comes first in the second part. So 2 is the first, and the x becomes negative. So the negative of -3 is +3. So to rotate clockwise, it goes from -3, 2 around to 2, 3. -3, 2 is this one, and it rotates around to 2, 3. So that's the new one for this. It's rotation. Okay, the next one, I've got some K's going on in here. K right next to the X and K right next to the Y. And when two variables are side by side, that means multiply. So where do you multiply? Well, if you look at dilation, it says the dilation factor of C would give you C times X or C times Y. They used C here, they used K here, same difference. So if you multiplied XY by K, then you would get something larger. And so this is a dilation. And if we had -3, 2, that maps to, now K has to be greater than 0. So let's say that K is 2. We're going to let K be 2. Then we would have 2 times -3, which is -6, and 2 times 2, which is 4. So that goes from -3, 2 to -6, 4. Now you can't really tell it's a dilation when it's just a point, so I'm not even going to graph this for you. But if you had a whole picture, say you were graphing a square or a triangle or something, where you had more points, you could see that the triangle got bigger or smaller. And same with the whatever the other shape was I said. I'm sorry, I forgot what I was saying already. But a shape would get bigger. But just a point, it only looks like it moved. It doesn't show you that something's getting bigger because there's nothing really there to get bigger. All right. This one, XY maps to -YX. So again, I've got switching going on. So I'm going to look down here at my rotations. That's usually where my switching is. Not every time, but that's usually where it is. And so I go from XY to -YX when I go counterclockwise 90 or clockwise 270. So this is a rotation again. And I'm going to say clockwise 270, although counterclockwise 90 would also be correct. And so if XY was -3, 2, then the Y comes first and it becomes negative. So it was 2, and the negative of 2 is -2. And then X stays the same, but it comes last. So that's -3. So my rotation clockwise 270 degrees goes from -3, 2 to -2, 3. And last, I have XY maps to -X, -Y. So XY maps to -X, -Y is again a rotation. And whether you go clockwise or counterclockwise, remember, I can turn this upside down 180, or I can turn it this way, 180. But either way, it winds up the same. So this would be a rotation, counterclockwise or clockwise, of 180 degrees. And no need to state clockwise or counterclockwise because they're going to both be the exact same. So if I had -3, 2, the X and Y stay in the same order, but they both become negative. So -3, the negative of -3 is 3, and the negative of 2 is -2. So that maps to 3, -2. Okay, so there is how you map the image and the pre-image to the image. Okay, now let's take a look at some where you have the picture. It says use coordinate notation to describe the transformation of PQR. So PQR goes from here to here. The image to the pre-image. The pre-image to the image, sorry. And so P was at -4, 5. Where is P now? Well, the new P is at 1, 2, 1, 2, 3, 4. So 2, 4 is where it went. Q was at -5, 2. Well, where is Q now? It's at 1, 1. And then R went from -1, 3 to over here, it's at 5, 2. Okay, so that is I'm sorry. That's what happened to triangle PQR. It went from here to here. It looks like a translation this way and this way, or it's technically just a translation in a diagonal line. You could do it straight across and then down, or you could do it in a diagonal line, but that's just a translation. Okay, describe the algebraic rule for DEF. All right, well, I got to see what's happening to DEF. D was at -2, 0, but it ended up at -1, 0. Okay, E was at -4, -1, and it ended up at -2, 1, 2, 3, -2, -3. Okay, and then F was at 2, -1. Oops, that's positive. 2, -1, and it ended up at 1, -3. Okay, so what happened? I've got to find a rule, and I know that this changed shape. So is this a rigid motion or a non-rigid motion? It would be non-rigid, right? And if it's non-rigid and it changed shape, then it's got to be a dilation. Okay, so what I'm seeing happening is -2 went to -1, -4 went to -2, and 2 went to 1. All of the x's went to half of what they originally were. So you have 1/2 times the x. And then what happened to the y's? 0 went to 0, so it could have been multiplied by anything. -1 went to -3, and -1 went to -3. So what would I have had to multiply -1 by to get -3? 3, right? So 3 times y. So we did 1/2 times x and 3 times y. So that is the algebraic rule for what happened to these two triangles, the image and the pre-image of DEF. All right, name the transformation described by the given rule. I'm going to let you guys do this in the slides because we just got through doing a whole bunch of those. And so get out your cheat sheets. I will do number 4 with you before I give you the slides because I want you to see how it is with the numbers. It's the exact same as when you have the XY. You say X stayed in the same place but turned negative. y stayed in the same place but turned negative. So this would be, on this sheet, it would be xy, x, negative y. So xy, negative x, negative y is right here. It's a reflection through the origin. So that is exactly what we would put here. Reflection through origin. Remember, origin is 0, 0. Okay, so I'm going to let you guys do the other three on a slide next. And then draw the image of each figure under the given transformation. So for number 7, I go from xy to x plus 4 and y minus 5. So this is going to be a translation, because when you have a plus and a minus, it's a translation. So number 7, if I have this point at negative 4, 1, it's going to map to x plus 4. Negative 4 plus 4 would be 0, and y minus 1, minus 5, so that would be 1 minus 5, or negative 4. So that's going to go to 0, negative 4, right here. Let's call this A. So this will be A prime. All right, then this will be B, and so it's at 0, 1. So 0, 1, I would have 0 plus 4, which is 4, and 1 minus 5, which is negative 4. So that would be at 4, negative 4, and that's my B prime. Okay, let's let this be C, and it's at negative 1, 4. So negative 1, 4 maps to what? Well, negative 1 plus 4 would be 3. And 4 minus 5 would be negative 1. So 3, negative 1 would be my C prime. And then D would be at negative 3, 4. So what does that map to? Well, negative 3 plus 4 is 1. And 4 minus 5 is negative 1. So 1, negative 1 is my D prime. That was D. So drawing this picture, that shows my translation from the pre-image to the image. I knew already before I started it was going to be a slide. All right, 180-degree rotation around the origin. Cheat sheet time. Rotation, find that. And then 180 degrees. Okay, that's where xy maps to negative x, negative y. So let me write that down. xy maps to negative x, negative y. All right, so I have another triangle with points A, B, and C. And so A is at 1, 0. So that's going to map to, they both just become negative. Negative 1, 0. B is at 1, 3. They both just become negative. So that's negative 1, negative 3. And then C is at 5, 0. And so that's negative 5, 0. I hope I didn't write where I needed to put points. All right, so mapping those, I have A's image would be at negative 1, 0. B's would be at negative 1, negative 3. Yeah, I did right over it. That would be B's. And then C would be at negative 5, 0. So this triangle looks like this. It reflected across this point. reflected about this point, I should say. So everything about it from this point is an exact reflection. Now that's really, I'm sorry, it's a rotation around this point. I keep saying reflection, but it's like if you took this and you turned it and you turned it again, that's where it would land. All right. And then last, a reflection. So reflection across the y-axis. The y-axis is the one that goes up and down. So I'm going to call this point A, B, and C. And it's going to reflect across the y-axis. So starting with A, I have the point -3, 2. Oh, and I didn't go get my rule first. Back to the cheat sheet. Reflection across the y-axis. XY goes to -XY. XY maps to -XY. So -3 becomes negative. So that's -3, which is 3. And y stays the same. So 3, 2. For B, I'm at 0, -1. Okay. The x becomes negative, 0 becomes negative, which is still just 0, and this stays the same. So that's going to be the same point, and that can happen. And then C is at -4, -3. Okay. X becomes negative, so -4 becomes +4, and y stays the same, which is -3. So I have 3, 2 for the image of A. I have 0, -1, so the image of B stays the same. And then for C, I have 4, -3. Drawing in this triangle, you can see that that is a reflection across this y-axis. It reflects exactly across the y-axis. Okay, I know this was a lot, but hopefully now you're all set to go and get your assignment done. I will also add a couple more YouTube video resources for you to look at some other people explaining the same thing. This is all brand new, so don't give up. Watch the videos. All right, talk to y'all later.